Okay, we're going to go on today and we're going to look at the frequency and the period of our sine and cosine waves. All right, so written below you see our general form for sine and cosine because they're really the same thing. Cosine is just a 90-degree shift of a sine wave. So we have here in different colors A, B, C, and D. We know that A is our amplitude. We know that B is our frequency. C is our horizontal shift, which we haven't really talked about that much yet. And D, which we did the other day, is our vertical shift, how much we shift up and down. So today we're going to concentrate on our friend B, the frequency. So written below here we have a cosine wave. Now we can look at this, and if we make each one of these 1, this is 3, and this is -3. Let's call this example number 1. It's a cosine wave, and it's period. Remember, a period is how long it takes to make one wave. So since we're looking at a cosine wave, how long did it take to make one complete cosine wave? In other words, how long did it take for it to start high, hit its lowest point, and end at its highest point? According to this, it took 2 pi. So this period is 2 pi. Frequency now is, and if I look here, I see one complete wave. So if I were to write the equation of this, this would have been y equals an amplitude of 3. It's a cosine wave who has a frequency of 1. We don't have to write that 1 there, but I'm just going to emphasize it. And then x, and there is no shifting going on. All right, so now you're going to have to figure out what 3 cosine 2x would look like. So in other words, I'm graphing the equation y equals 3 cosine 2x. And we'll call this example number 2. So again, I'm going to start getting myself with a regular cosine wave. That's what I get my mind straight at. So a cosine wave would start at 1, it would end at 1, directly in the middle, it has a low of -1, and then directly in between those 2 points, it hits zeros. So this is what a regular cosine wave looks like. Now, how do they want me to change that? Well, first of all, they want it to go 3 high. So that means each one of these points is going to get tripled. 1 triples to 3, 0 triples to 0, -1 triples to -3, 0, and then +3. So there, I've just drawn a cosine wave with an amplitude of 3. But now let's look at that B value real closely. This, remember, is the frequency. So if I come back here and look, remember, frequency is how many complete waves you see in 2 pi. This is telling me we'd like to see 2 complete waves in 2 pi, which means I've got to shrink this down and fit it, 2 of those, into 2 pi. So that means one of them is going to have to fit into just pi. And that still is, it has to look something like that. So here's pi. And in this box of pi, I have to fit one cosine wave. Let's see, did I do it? Starts at 3, ends at 3, and directly in the middle it's at -3. So now basically I have to do that again. So here's my next pi. And there you go. If I take away all my aids that I used to draw this, Let's see what I got. This is saying I have to have an amplitude of 3. Yep, 3 high, 3 low. This is saying I need 2 cosine waves in 2 pi. 1, 2. Done. And you can always check yourself on a calculator. So here over on Desmos, I have it set up. I came over here to my settings and I changed my settings, even though it changed it into decimals. I went by pi over 2 or 90 degrees. And then over here, I can type in y equals 3 cosine 2x. And there's my graph. And I can clearly see that I'm up here at 3. I'm down here at 3. There's my complete wave. There's 1 in 180. And then here's my second one in 2 pi. So what would 3 cosine a half look like? Well, hopefully by now we can start taking some shortcuts. You should be real familiar with a cosine wave. So 3 cosine 1/2 would mean I'm 3 high and I'm 3 low. And then in between I hit 0. And if I were to graph this, there's my cosine wave. But now I have to come into play with that frequency, 1/2. So once again, I'm going to grab this so I can tell myself that this number tells me how many complete waves I should see in 2 pi. Well, I should see, according to this, only half a wave. So I'm going to come back here with that box and realize that this is what half a cosine wave looks like. And that needs to be stretched out along 2 pi. See, I want half this wave in 2 pi. All right, so that means I'm going to start at 3 and end at -3. So I'm going to adjust this picture. So it tells me I want to start at 3, but I only want to see half a wave, so that means I want to end at -3. And then halfway in between a high and a low, I know I'm going to hit 0. So that's what a cosine would look like. So if I studied this more, I've got my amplitude is 3, check. My frequency is 1/2, so do I see half a wave in 2 pi? Yes. But what if they ask me, what's my period? All right, so how long does it take me to make one complete wave? Because that's what period means. How long it takes to make one complete wave. Well, that's not so hard to figure out. If it takes me 2 pi to make a half a wave, then it must take me 4 pi, double that, to make a full wave. Right? So if I went back here and graphed a full wave, which sometimes they ask you to do, they ask you to graph one complete cycle, there's a cosine wave. So sometimes they'll just ask you to figure out the period and the frequency just by looking at them. Well, we can always graph them. So just to show you, let's do y equals 6 sine of 4x. So I'm going to go back over here to Desmos. I'm going to type in y equals 6 sine of 4x. And here we go. Let's put these down now, these words. How long it takes to make one complete wave. And how many waves you see in 2 pi. So let's get our words straight with them. How long it takes to make one complete wave is our period. And how many complete waves you see in 2 pi is our frequency. Well, our frequency is easy. It's always what's in front. Now, I should tell you that you should factor out that. So this should really be written 6 sine 4x. That's going to become very important when we start doing vertical shifting. Oh, sorry, horizontal shifting, which we haven't seen yet. So get used to always factoring that out. Now you're sitting here going, that doesn't make a difference. It will later on. So how many complete waves do you see in 2 pi? Well, that's my frequency. I see 4 complete waves in 2 pi. Well, how long does it take to make one complete wave? Well, if in 2 pi there are 4 waves, then it should take pi over 2 to make one complete wave. Let's go back to Desmos and look at that. All right, so there, right here, that's 2 pi. And let's see, there's 1 sine wave, 2 sine wave, 3 sine waves, 4 sine waves. Okay. And if I look how long it takes to make one, pi over 2. All right, how about for this one? Now they're talking it in radians. So again, I'm going to rewrite this. I'm going to factor out that pi over 3. And the frequency. Well, let's start with how many complete waves you see in 2 pi. They're telling me I see pi over 3. Huh? How long does it take to make one complete wave? Well, that's still 2 pi divided by pi over 3. All right, so I got to do some math here. 2 pi times 3 over pi, boom, boom, 6. All right, so it should take me about 6 to make one complete wave. And this is not 180 divided by 3 is 60 degrees because they want us to look at in terms of radians. So this is 3.14 divided by 3, and we'll say approximately because we're abbreviating pi. So it's approximately about 1 to make a complete wave. So let's do this. 8 cosine pi over 3. Let's go over here to Desmos. Let's change this out. Y equals 8 cosine pi divided by 3. Whoops, that's not what I wanted. Pi divided by 3. All right, just to make it quick. All right, so cosine wave. So here we go. Hi, let's get this out of the way here. Boop, there's my complete cosine wave. Look at that. When I go over 6 on the x-axis, I get back to my beginning. So that's how long it took me to make one complete wave. 6. Just like I said over here. And how many waves do you see in 2 pi? I said I should see about 1, roughly about 1, or pi over 3 is the real thing, real answer. If I come over here, and remember, here's pi right here. That's 1 complete. So I see 1 cosine wave and just a little tiny bit more. And the last one, well, I'm going to rewrite this. Y equals -12. Oh, thank goodness they're not using radians anymore. They're using a number that I like. It's really radians, but we're not going to tell you that. It's an exact. So how many complete waves do you see in 2 pi? According to this, I should see 2/3. So my frequency is 2/3 of a wave. And how long does it take to make one complete wave? Well, in 2 pi, if I see 2/3 of a wave, that means 2 pi times 3 over 2, cross that off. It should take me 3 pi to see one complete wave. Go back to Desmos. Change this. We got y equals -12 sine 2 divided by 3x. All right, so let's adjust this window a little bit so you can see everything. I'm going to zoom out. All right. That looks good. So what did we say over here? We said 3 pi it would take to see one complete wave. Well, where's 3 pi? There's 3 pi right there. Is that one sine wave? Yes. Remember, it's upside down because it was a negative 12. So we're right. It took 3 pi to make one wave. All right, how much would it take to see what's in 2 pi? I should only see 2/3 of a sine wave in 2 pi. So if I come back here to 2 pi and I follow it, 2 pi is right there, roughly. Trying to get it to there, that's as close, 6.28, there we go. And if I notice, I've got my valley and I almost 2/3 of a full sine wave.